Hey guys, today we're going to take a look at the Cartesian equation of planes. Okay, so this is just another way of coming up with an equation of a plane. However, this one's going to look a little bit more like a traditional equation that you're used to from, grade 9, 10, and 11. Okay, so first of all, the normal equation of a plane. So a plane may be determined by a point, P, which is on the plane, as well as a vector, and the vector has to be perpendicular to the plane. Perpendicular to the plane called the normal. Okay, the normal. All right. Well, we're going to call it the normal vector, actually. I'm going to call it the normal vector. Normal vector, okay, which we would write as n. Okay, we write as n, like that. All right? That's pretty sloppy, but whatever. It'll be fine. All right, so if P, x, y, z is a generic point on the plane, then the point we create from this point that's given on the plane to that generic point, okay, is perpendicular to n. Okay, it's perpendicular to that normal. So any vector created in this plane is perpendicular to n. Now, what that means then, so I'll say and thus, if we were to take that vector, that generic vector somewhere on the plane, and we take the dot product with the normal, it will always equal 0. Okay? So this actually is what gives us the normal equation of a plane. Let's see. So the Cartesian equation of a plane, if n is ABC, is known on the plane. So if we use this here that we derived and we sub it in, I'm going to kind of skip through actually how it's kind of derived because it's really not that interesting or relevant. But what this gives us is if we have a normal A, B, and C to the plane, then what we can do is we can come up with the equation, and it'll just be AX plus BY plus CZ, and then we have plus D equals 0. Now you might think, but where does that D come from? And that's where you're going to have to use that point, because the normal itself will only tell you sort of the positioning of the plane. It won't tell you where it is, and so you will need to use a point on the plane to determine that D value. Okay? So this is what's really important here, is just this equation here. This is what it looks like, and that is when the normal is A, B, and C. Okay? So, before we move on and actually use that, it is worth noting that if two planes are parallel, and you'll see this if with two F's, that means if and only if, which means that it's if one thing is true, the other thing is always true. That's just it's kind of a fancy way, or a lazy way to write a fancy thing. So anyway, if the two planes are parallel, then the normals, okay, the normals will also be parallel. Okay? Similarly, if two planes are perpendicular, then the normals, and this will shock you, will be perpendicular. There we go. Okay? So let's actually use this to do something here. So I'm going to give you a plane, and the Cartesian equation here is 2x minus 3y plus 6z plus 12. So if I want to find the normal vector for this plane, the vector that is perpendicular to this plane, I can just say n. I'm going to zoom in. You have your sheet in front of you. You can look at it. So yeah, so the n value is just going to be, and you're just going to take those three the A value, the B value, and the C value. So we'll have 2. And then we had a minus 3y, so it'll be minus 3. And then we had a plus 6z, so we rate a 6. And then that D value again. When you're coming up with the normal, it's not relevant to it. So that's all there is. Okay? So that's fairly straightforward to find that. You just take it right out of the equation. You don't actually have to do any computation. Okay? So we're going to find 2 points on the plane, and this is relatively simple. There's obviously an infinite number of points we could find, but let's just, to make it easy, let's just say x is 0 and y is 0. Okay, then we would have 2 times 0 plus, or sorry, well, it would be minus, but I guess it doesn't really matter, minus 3 times 0 plus 6 times z plus 12 equals 0. So that's just going to give us that z equals negative 2. Okay? So the first point would be 0, 0, negative 2. Okay? And then we can show, a way to show that that is on the plane is you would then say is on pi. Okay? So similar to when we said is an element of the real numbers, this is saying it's an element of pi. This point lies on the plane pi. Okay? And I'll do it smaller here for the second one because I kind of ran out. But we can just say if, let's leave x is 0 again, and we'll say z is equal to 0 this time. Okay? Then we would have 2 times 0 minus 3 times y plus 6 times 0 equals, well, I guess it'd be negative 12. I didn't mean to write equals, but I'm making a mess of it. That's okay. So we got negative 3y equals negative 12, which means that y equals 4. Okay? So we would say 0, 4, 0 is an element of pi. That's really messy. I'm going to... Oh! What just happens? It just erased everything. Hold on. Oh, we're cool. Whew. All right. There we go. Sorry. Well, that was dramatic. All right. So there we go. All right, so let's find if the point is on the plane. This is simple enough. This is no different than what you would do if you were doing, your grade 9 stuff, finding if a point was on a line. Okay, we just take the equation and we sub in this point. So we say 2 times 1 minus 3 times 2 plus 6 times 3 plus 12. And we just find out what that equals. Okay, so that's going to be 2 minus 6 plus 18 plus 12. Let's see. So that's going to equal 26. Okay, and that's not good enough. Okay, that does not equal 0. Does not equal 0. Therefore, and what we can do is we can say the point P is not an element of pi. Okay. See, in math, we're just trying to stop writing words and use as many symbols as possible because we're the laziest people in the world. So anyway, so we're going to find the Cartesian equation of a plane that passes through A, B, and C, given there. Okay, so this is a pretty standard type of question that you can be doing on this kind of stuff, and it's not terribly difficult. Okay, you just have to use your brain, and you'll see that it's not that bad. So the first thing we're going to do is we're going to find the two direction vectors. Now that there are three possible ones we could find with these points. I'm going to find A, B, and AC. So I'm just going to call the first direction vector U. So we'll say U is A to B. Okay. Which just means, remember, we're just subtracting the values. So the direction vector then would be -1, 1, 1. Okay, so that's my first direction vector. Okay, my second direction vector is going to be AC. We'll do AC. Okay, I'm going to bring it over here so I don't mess it up. Okay, and all that's going to be is -1, -1, +1. Okay, And so those are my two direction vectors. So to find the normal vector, okay, to find the normal vector, I have to realize, so this is going to be, the normal vector is going to be perpendicular to both u and v. So if it's perpendicular to u and v, well then it's just going to be the cross product of u and v. And I probably should have written this up top somewhere. So I'm just going to put a green box around it because this is important. Okay, that's how you're going to do almost all these questions. Okay, and so to do that, I'll just write them over here. We'll say, well, I'll do it in blue so that it's clear. It's just off to the side. Remember, you start with y. Why? I don't know. And then -1, 1, -1, -1. So there we go. So there's our things, and we had 1 times 1 minus -1 times 1, 1 times -1, and that. And so what we're left with is 2, 0, 2. Okay. So there we go. So there's our normal vector. Now we have our normal vector, which of course, and you wouldn't have to actually write this step, but I'm going to write it so you can see what I did. That's the same as having A, B, and C. Okay? So now, from there, I can say, well, what was it, 2, 0, 2? So I can say AX plus BY plus CZ plus D equals 0. So I can just sub these in. I've got 2x, b is equal to 0, so I'll say plus 2z, and plus d equals 0. So the only thing I don't have here then is d. So what we need to do is we need to sub in a point. And it doesn't make a difference. You can sub in A, B, or C. You'll get the same answer. I'm going to sub in A, and I'm going to get 2. Sure, here, I'll write that down actually. Sub in A. Okay? So we'll get 2 times, and x was 1, plus 2 times, and z is 0. Okay, there is no y in this equation, so that worked out nicely. Okay? So obviously 2 times 0 is 0, so we just get that d is equal to -2. Okay, so therefore our equation is just 2x plus 2z minus 2 equals 0. Okay, now we could actually, if you wanted to, you could actually simplify this further, divide everything by 2, and get that as your final answer. Okay, and there you go. Okay, so let's move on here. Okay, I'm actually going to leave those top 3 questions for you, and you're going to attempt them, and then we'll take them up in class as needed. And let's take a look at the angle between 2 planes. So, the angle between 2 planes is defined as the angle between their normal vectors. Okay, so we just find the angle between the 2 normals, and that will be the same as the angle created from the planes. So to do that, we're going to say, we're going to use the equation cos theta is equal to, and on top we'll have the dot product, okay, and we'll divide by the product of the magnitudes. There we go. Okay. Note, using this formula, you may get an acute or obtuse angle. Obtuse angle. And both are correct. The only reason you would need to specify really is if the question actually specifies whether it wants the acute or the obtuse. Okay? All right, so let's take a look at...
Angela Boardman to the office, please. Angela Boardman to the office.
Okay. Obviously, I'm at the school when I'm making this video. So, Example 6, so I've got two equations here. We're going to find the angle. So to begin with, we're going to say, well, what are my normal vectors? So normal vector number 1 is going to equal, and we just look at the coefficients. So we've got 1, 2, whoops, what just happened? 1, 2, 3. So there's my normal vector number 1. Normal vector number 2 is going to be 3, 2, 1. And again, you'll notice that the d values aren't important here. They don't have any effect on that, because that's just telling you where the planes are. It doesn't matter. All we care about is the positioning for this. Okay? So now I'm going to use the formula, which is cos theta equals, well, I'm just going to, whatever, I got the formula written right up there. So I'm just going to go right into it. I'm going to say I've got 1 times 3, because I'm doing the dot product here, plus 2 times 2, plus 3 times 1. Okay, and then we divide by the magnitude of them. So we got 1 squared plus 2 squared plus 3 squared times 3 squared plus 2 squared plus 1 squared. Okay, there we go. And so then that works out to be 10 over 14. So then theta is equal to the inverse cos. Don't forget to do this last step. A lot of the times it's easy to just, you get to that 10 over 14 and you're just like, oh, that's the answer. And of course, I know you guys know how to figure out the last part, but it's easy to just forget to do it. So it works out to be about 44.42 degrees. Okay. And there we go. So I want you to try the last one there by yourself. It's fairly simple. It's exactly the same as that last one. And so until next time, go Sabres!